Study Section 5. Principles of Probability and Methods of Counting. Introduction. Probability is also known as the study of randomness. It is purely a game of chance. The exact outcome or result is not predictable in advance, hence it is void of favoritism or biasness. Randomness is most easily noticed in many repetitions of games of chance, rolling dice, shuffled cards. The theory of probability lies on uncertainty, haphazard. This study session will discuss the probability as well as the definition of some basic terms. Learning outcomes for study section 5. At the end of this study session, you should be able to define probability, distinguish between the 5 probability sampling techniques. Probability. Probability is a mathematical expression for the degree of belief which we have about something. When we talk of probability, we cannot do without mentioning some terms. These include random experiment, trial, outcome, sample space, event, mutually exclusive event, mutually exhaustive event, and independent events. Let me quickly define these probability terms. A. Random experiment means performing an act which, when repeated, generates a number of outcomes that is not predictable. For example, the outcomes in a throw of a fair dice. B. Trial is simply one act performed. Example is a toss of a coin once. C. An outcome is one of the possible results in the trial of an experiment. D. Sample space is the collection of all possible outcomes of an experiment. It is usually represented by S. E. Event is a subset of a sample space. It is the collection of outcomes which have certain characteristics in common. F. Mutually exclusive events. 2 or more events are said to be mutually exclusive if the occurrence of any one of them prevents the occurrence of others. That is, at least 2 events cannot occur together. Example, the occurrence of 1 prevents the occurrence of 2, 3, 4, 5, 6 in a throw of a die. G. Mutually exhaustive events. 2 or more events are said to be mutually exhaustive if they constitute the sample space. H. Independent events. 2 events, A and B, are independent if the occurrence of A does not affect the occurrence of B. That is, the probability of B is the same whether or not A has occurred. Approaches to probability definitions. Probability, which is a measure of likelihood that an event will occur, can be defined in 3 ways. These are subjective approach, axiomatic approach, classical approach. Subjective probability. Subjective is the opposite of objective, that is, based on individuals' belief or judgment. Therefore, the probabilities assigned to any event based on subjective probability, which is also known as personal probability, are influenced by biases or personal assessment of the person assigning it. Can you think of any? Let me give 2 examples. 1. The probability that you can finish a bowl of eba in 20 minutes. 2. The probability that Shegun, who is a second-year student, will get accommodation in his third year. Subjective probabilities are rarely used in practice since it lacks theoretical background. Classical approach. It is used to predict outcomes of gambling games. If an experiment can produce W different and mutually exclusive results, if X of these are favorable, then the probability of a favorable result is X over W. The probability of occurrence of the event success is denoted by P. The mathematical expression for P is equal to probability of E is equal to X over W. The probability of non-occurrence of the event failure is denoted by is equal to 1 minus probability of E. Thus, P plus Q is equal to 1. In classical approach, probability of intersections of event, conditional event, and union of events can be calculated. Example, let E be the event that an odd number turns up in a roll of a die. Solution, in a roll of a die, the sample space is 6. E is equal to 1, 3, 5 is equal to 3. Probability of E is equal to 3 over 6 is equal to 1 over 2. Axiomatic approach. There is a saying that fingers are not equal. The classical definition of probability is not always true in real life because all events are not equally likely. Probability is taken to be the relative frequency of occurrence of an event when the number is very large. The more reason why some authors call it limiting frequency approach as n increases indefinitely. Example, if tossing a coin 500 times results in 234 heads, the relative frequency is 234 over 500 is equal to 0.468. If 500 another results in 287 heads, then the relative frequency is 234 plus 287 over 1000 is equal to 0.521, such that if we continue in this manner, we should be able to get to a number that represents the probability of a head in a toss of the coin. Counting techniques. Counting techniques are methods developed to solve problems when it becomes laborious to determine the sample space or outcomes in a particular event. Such experiments are roll of more than 2 dice, coins, etc. The methods developed are 3 diagram. Although this cannot be used for complex events, but it is a way out for determining outcomes in sample spaces that the outcomes are not many. E.g., in 3 tosses of a coin, we have for the first toss, H, for the second, for the third. Example, 1 over 3 of a fish pond are catfish, while others are tilapia. 1 over 6 of the tilapia species weigh below 20 kg. 1 over 2 weigh exactly 20 kg and 1/3 above 20 kg. For the catfish, 1 over 8, 1 over 2, 3 over 8 respectively. For all the weight, the chance of survival of a fish 2 over 3. A. Draw a probability 3 for the information above. Solution. Let C is equal to catfish, T is equal to tilapia, B is equal to below 20 kg, E is equal to exactly 20 kg, A is equal to above 20 kg, S is equal to survivor, O is equal to others. Different probabilities can be calculated with these 3. For example, 1. What is the probability that randomly selected fish from the pond will not survive? P0 is equal to, this is the sum of all probabilities that a fish, tilapia or cat will not survive, is equal to 0.333. Permutation is the ordered arrangement of n different items taking R or n at a time, and it is denoted by n permutation R. N permutation R is equal to n factorial over n minus R in bracket factorial, where n factorial is equal to when n distinct items are taken all at a time, then n permutation n is equal to, remember, 0 factorial is equal to 1. Therefore, n permutation n is equal to n factorial is equal to the permutation of n things of which some of the selected items are alike, that is, n1 are alike n2, n3. Therefore, n factorial over n1 factorial, n2 factorial, n3 factorial, where n is equal to ny plus n2 plus the number of permutation of n different items taken r at a time when each item may occur a number of times is n raised to power r. Also, the idea of permutation can be applied in the formation of numbers with digits and words with letters, some without restriction and otherwise. Example 1. How many 3-digit numbers can be formed with 1, 2, 3, 4, 5 if repetitions are not allowed? 2. How many number of permutations of letters in minimum? Solution 1. 5 permutation 3 is equal to 5 factorial over 5 minus 3 in bracket factorial is equal to 60. 2. Since some of the items are alike, then we have to apply n factorial over n1 factorial, n2 factorial, n3 factorial is equal to 420. Combination. The number of arrangement or selection of n different objects taken R, that is, sum or all of the number of things at a time with no consideration given to the order of arrangement, is referred to as combination. It is denoted by n combination R is equal to n combination R is equal to n permutation R over R factorial. Example A. In how many ways can a committee of 3 people be formed out of 20 people? B. A boy has 7 fruits, each of a different variety. How many different Jewish tastes can be made? Solution 20 combination 3 is equal to 1140. B. He can choose 1 out of the 7 fruits, 2 out of 7 fruit, 7 out of 7. Therefore, is equal to 127, or 2 raised to power n minus 1 is equal to 127. Summary of study section 5. In this study session, you have learned that 1. Probability is a mathematical expression for the degree of belief which we have about as take 2, which we have about something. 2. Subjective probability is the opposite of objective, that is, based on individual's belief or judgment. Combination is used when the order is of no importance, otherwise permutation is used. 3. Classical approach is used to predict outcomes of gambling games. This is the end of study section 5. Thanks for listening.